Okay, so let's consider the particle in the infinite, in the 1D prison, and we know that the eigenfunctions of energy are square root of 2 over L sine n pi x over L. And let's imagine that the particle is in an eigenstate. So, of course, psi of x and t is given by that, and let's imagine that we want to find the expectation value of the position in such a state. Of course, this would be psi star x psi in dx, and that would reduce to 2 over L, integral from 0 to L of x, and psi star psi just gets rid of the time part, and we square the other part. So we get sine squared of n pi x over L in dx. And if we want to do the integral directly, of course, we then have to figure out, we can replace dx with some other variable, say this one, and do the calculation. But we know that we can figure out what the answer is by the simple fact that these functions, and in particular the square of those functions, have a certain parity. So, so psi 1 of x, as we know, looks like that, 0 to L. Psi 2 of x looks like that, but psi 1 of x, so the point here is that this psi 1, and of course all the psi n of x's with n odd are symmetric about L over 2, and so are the psi odd ends squared, right? When you square these functions, that the parity doesn't change. The functions are still even. But for these functions whose parity is odd, when you square them, of course, psi 2 of x squared will become an even function. So we'll get 2 bumps. Well, I made a mess of that, but it's a smooth function. But the point is, you'll square this function and you'll have an even function. So all of these functions, when you square them, become even, and that means that the probability of finding them on one side versus the other must be the same, and so the average value must be the midpoint. It can't be shifted anywhere else with respect to that. So we know from these considerations that in eigenstates, the expectation value must be the midpoint, which in this case is L over 2.